A-level physics, paper 3. Let's hope it's a little bit better than paper 2 was. My paper 2 last year was insanely hard and the exam board was issuing apologies for that, and they've gone and done it again. So don't feel too disheartened. I thought that I had absolutely messed up on that paper. I thought it was absolutely abysmal. Turns out I got the highest mark on that paper. So you might be having done a lot better than you actually think you have. Regardless, that exam has passed. You've now got physics paper 3. This is probably the last exam for a lot of people, or you might have maths slightly later on, which I will be doing a video on as well. But focusing in on paper 3, we're going to be going through what examiners are constantly saying students get incorrect. Now, for something like AQA, there are a lot of different versions of section B, so I'm going to be giving some very general advice for section B, but this is applicable to every single one of the different sort of subtopic areas. For context, I did the medical physics module, which I know a lot of schools do not do, but at our school there were a lot of people who wanted to become doctors and were taking physics, and therefore they sort of chose the medical physics module. It would not have been my choice, but I did it and I moderately enjoyed it. So we're going to go through what examiners want to see, how you're going to be maximising your marks, and some general tips for making sure that you're able to absolutely smash this exam. And if you did not do as well on paper 2, then you're going to be able to recuperate those marks on paper 3. Section A of this paper is based on required practicals, and it's a very synoptic section that looks at a lot of different topic areas from across the specification. So this makes it really important for you to actually have a really solid foundational idea of what the different topic areas are in physics and how they relate to each other, because a lot of these questions won't be testing a specific topic area. They will be testing the sort of intersection of lots of different topic areas, which, if you're not familiar with, makes this paper very hard. And it's very difficult because there are limited past papers, and other than past papers, there are very few resources that are targeted towards this specific part of the physics examinations. So that makes these tips really, really important. The first tip that I can give you is make sure you have a good understanding of practical skills, because these practical skills are what is being assessed, and they want really precise understanding and precise language to match that understanding. So for example, if you're talking about a ruler, you can't say make sure the ruler is straight, you've got to say make sure the ruler is vertical. That is, or horizontal, whatever is actually looking for, but saying it must be straight won't get you those marks. Do you see how there is a difference in the precision of the language being used? That is what they are like across every single one of those questions. So you've really got to get to grips with things. The best thing you can do is go on Physics and Maths Tutor or similar websites and just get question packs, required practical question packs, and just blitz through them. Because yes, there are lots of different required practicals, but they all in the style of questioning will be testing the same thing. You need to be able to write detailed technical explanations, and for every step, make sure you're naming the equipment that you're using and why you are taking that step. So for example, is it to improve accuracy? Is it to improve reliability? Is it to disregard anomalies? Whatever it is, you've got to be really precise about what you're doing it with, and why you're doing it. When you have to use graphs, make sure that you are using the most fundamental basic things that get you marks. Naming it, giving it a title, labelling both of the axes, making sure you've chosen an appropriate scale. If you are drawing a line of best fit, you need to stop and consider, okay, does it need to go through the origin? Because sometimes your line of best fit will go just above the origin, and that is completely fine if the two variables aren't both at 0 at a certain point. But if they are, then obviously it needs to go through that origin. And that's the sort of thing that separates students who are going to be getting Bs from those students who are going to be getting As and A stars, and that's where you want to be aiming. So that is the level of detail you've got to be thinking in. And again, reiterating, for multi-part calculations, write down every single step, even if it is the most basic thing, just put it down there. Make sure you give it to an appropriate number of significant figures. So give it to 3 significant figures unless you're told otherwise, is the general rule of thumb. But you're also making sure that you never prematurely round. So you never prematurely have 3 significant figures. Let's say you do the first stage of the calculation and you end up with some sort of number with a lot of decimal places, and you truncate it and you just have a look at like the first 2 decimal places, and then you use that for the rest of your calculations. You're going to be off, and that is going to be an error that you are going to be marked down for. So always use the exact value that your calculator gives you. Obviously on your sheet of paper you can write down it to 2 decimal places. You don't have to write down all of the decimal places that you're given, but in your subsequent working you've got to actually use the exact value on your calculator, not what you've written down with like 2 or 3 decimal places. Questions on error and uncertainty are really very common in this exam. So you've got to be familiar with how you use both error bars and also line of best fit, line of worst fit in order to be estimating uncertainty and using uncertainty in calculations. So, for example, when do you add the uncertainties, when do you multiply the uncertainties, you've got to have these really easily retrievable in your brain because you can almost guarantee that it will be coming up. And you've also got to think about strategies that reduce the uncertainty, things like increasing the range, repeating the measurements. That's all about section A, but let's think a little bit more about section B. This is the section that is to do with the sort of specific topic area that your school has elected to do. So there are a bunch of options from astrophysics, there's medical, there's engineering physics, there's turning points, there's electronics, but they all follow standard marking procedures. And we're going to be going through tips that are going to help you no matter which one you're doing. First of all, almost all of these options include diagrammatic elements, which in testing will involve you drawing or annotating diagrams. When you are doing this, you've got to make sure that you are very, very clear. If you mess up, then it is 9 times out of 10 going to be better for you to completely scrub that out and use the extra paper at the end of your test. Yes, it might be lined paper, which makes it slightly more difficult, but you do not want any ambiguity. You don't want the examiner to be thinking, well, maybe they got this right or maybe they didn't. They will just mark you wrong. If there is ambiguity, you'll get it incorrect. They won't give you the benefit of the doubt. So you don't want that to happen. You've got to be really clear with your sort of diagrams and make sure that when you are given the option to draw a diagram in the question, you use it. Because let's say your written answer will only get you 4 marks. The diagram that you draw might get you an extra couple of marks. So always, if you have the time, elect to draw a diagram, even if you think it's not going to be immensely helpful. Then they absolutely love the concept application math skills. So they'll talk you through a little concept, you might have to write a definition, you might have to explain a process, and then you will have a maths question based upon that process or that sort of key area of the specification that you have just discussed. Again, all of the general rules about writing down all of your steps, but particularly you have the formulae. So these options are not about memorization. You will have the formulae that you need to be able to answer these calculation questions. So make sure that even though it can be tempting when you think you know the formula to just jump straight into answering the question, do just refer back to the formula booklet. And I know that sounds so basic, but when you're in the zone, you just might not think to do that. So always go back, always have a look, and always make sure that you are actually using the correct equation, because sometimes you can leap to conclusions based upon what the previous sort of question was about. You might be thinking about how past paper questions had tested this specific subject, but make sure that you are just like doing the exact thing it asks you to do, because there are limited past papers. So you've only been exposed to limited questions within your specific topic area. There aren't many resources on it. So never assume what the question is asking you to do. Always properly take it in. And again, that can sound so basic, but it is under stress, and it is like likely to be one of the most unfamiliar topics to you because you will have learned it so close to the exams. You might have only had a month to revise this topic between starting it and being examined on it. And in this situation, that makes it uber important that you are taking the time to like really, really read the questions as carefully as you possibly can and thinking more broadly about the topic area as a whole. So the best thing that I could recommend that you do the night before physics paper 3 is you try and do some blurting on this optional sort of, well, it's not optional because you have to do it, but on the option that you have chosen to complete for section B. So just try and write down as much as you can, everything that you can remember about this topic. It's not going to be as fresh in your mind as electricity will be, for example. It's going to be something that you aren't going to have as deep an understanding of. But if you can do this blurting, if you can think about everything you've learnt related to this topic, condense it all onto a sheet of paper, and then go away and take a look. There are some wonderful YouTube channels like Science Shorts, which produce mind maps that go through all of the areas related to these optional modules. Watch one of those and compare. Did you get everything down? If not, have a look at those areas that you missed out. Did you get everything correct, crucially? And if not, these are very sort of general, they are broad topic areas. There are lots of animations online that you can find that relate to certain areas. So for example, I was doing medical physics, I would find animations for how x-rays worked. And I would go away and I would use that to enhance my knowledge because yes, it's not directly coming from this animation is for AQA A-level physics paper 3, medical physics module. No, but it's still the same principle that I'm learning. So don't be afraid to use those other resources, particularly the night before when you just want to see something presented to you in a different format. So those are my tips for your AQA A-level physics paper 3. This is your last paper in physics. Congratulations for making it this far and for making it through paper 2 because that was not an enjoyable paper. And I hope this paper goes a lot better for you. I will see you in the next video.